Hello and welcome to Empowered Learning. This video is about how to evaluate an expression called the difference quotient by using a polynomial function. So before we get started, the one thing that I want to make sure that we all understand is that this difference quotient is really just a fancy way of trying to express the slope of a line. And so if we had some function f of x and we had 2 points on that function that we've identified. Let's say we have the point x f of x, and we also have another point, horizontally speaking, h units away from this point. So that would make the corresponding x value x plus h, and then the corresponding y value to that would be just taking x plus h and plugging it into or evaluating it for f. And so that would be f of x plus h. And so now if we realize or recall that our slope of a line function is just the change in y values over the change in x values, then if we label this x1, y1, x2, y2, then you will see that when we write this all out, our y2 is f of x plus h minus y1 is f of x, and x2 is x plus h, and x1 is just x. And of course, these x's here cancel to 0, and we just end up having the difference quotient here. So that is actually what you're doing. So you're trying to calculate the slope of 2 points that, if you use those 2 points to intersect a line, is called the secant line for that particular curve. So this is what we're actually trying to find out. And we use the difference quotient to give us a general idea of rate of change based upon how far these 2 points are from each other. And this is a fundamental expression used in being able to define a derivative in calculus. So that's one of the reasons why it's important and why we have you evaluate these things. So I'm going to go ahead and clear this, and then after that we'll actually go through figuring out what this particular expression will be if our function is negative 10x squared plus 5x plus 4. Okay, so now that we have that cleared out, there is normally a couple of different ways that people evaluate this. One way is to do this all together, and another way is to do it piece by piece. To try to be a little bit more clear, I'm going to evaluate this expression piece by piece. So what that means is that I'm going to figure out what f of x plus h is first, and then I'm going to take that and subtract that answer from f of x and then divide everything by h. So I'm going to do this in 3 steps. So the first thing I need to do is find out what is f of x plus h. And so this literally just means everywhere where I see x here, I'm going to replace it with x plus h. So if I do that, I have a negative 10 times x plus h, quantity squared, plus 5 times x plus h, plus 4. And so now from here, I just need to multiply out what x plus h quantity squared is. So that's like x plus h times x plus h, and also distribute here. So we have a negative 10, and x plus h times x plus h is just x squared plus 2xh plus h squared. And then to distribute for these 2 terms, we have 5x plus 5h, and then that is plus 4. And so now the very last thing that we need to do is just to distribute the negative 10 to all 3 terms here. Okay, so if we do that, that will give us a minus 10 x squared minus 20 xh minus 10 h squared. And then we just write everything else. Okay, so that's the first part. Second part is now we're going to take f of x plus h and subtract that from f of x. So literally, we're going to take everything that we see here and then just subtract from that what we have here. So I'm going to just rewrite everything that I have for the f of x plus h. And then I'm going to subtract from that and put in parentheses, because remember, I'm subtracting all of it, what f of x is. And f of x is negative 10x squared plus 5x plus 4. And it's important here to put that in parentheses there to make sure that you know on this next step here that this subtraction sign is like plus times a negative 1, and we need to distribute that to all three terms here. If you don't put the parentheses there, there is a chance that you may forget that you're actually subtracting all of f of x, and you may just do this first term, and that's it. Okay, so here we have negative 10x squared minus 20xh minus 10h squared, and then we just keep on writing everything else. And of course here, for these last three terms, we're just going to change the signs. So what was positive is now negative, and what was negative is now positive. Okay. So all of this is what x plus h, or f of x plus h minus x, sorry, f of x plus h minus f of x. That's what this is, okay? But we're not finished yet, okay? Here is probably the most important part in this step, in my opinion, is that we know that once we're here, one of the main things that we're going to see is that every term that does not have an h in it should be able to cancel out with some other term. So for instance, we see that we have a negative 10x squared here. Well, that doesn't have an h in it, so we should be able to have a positive 10x squared that's in here somewhere, which is right here, that will cancel to 0. So negative 10x squared plus 10x squared cancels to 0. This term has an h in it, we leave it alone. This term has an h in it, we leave it alone. 5x does not have an h in it, so this should be able to cancel out with a negative 5x. 5h has an h in it, leave it alone, but 4 does not, so there should be a negative 4, which is right here, that cancels to 0. And so this is how you know you're doing this correctly. If you get to this point in the process and all the terms that do not have an h in it do not cancel out with another term, then you've done something wrong. So you need to go back and evaluate what you've done to see where your mistakes are. All right, so to finish this out, we're going to now do f of x plus h minus f of x, all that divided by h. So we got everything that we had left here, and I did forget to do this, so let me go ahead and write this now. This ends up being a negative 20 xh minus 10 h squared and plus 5h. Okay. And let me see if I can move all this down. All right, so now that we have that, then we know that we just have a negative 20xh minus 10h squared plus 5h, all that divided by h. And so here's what we're looking for. And if you notice, every term in the numerator has at least one h, so we can factor out an h at every term in the numerator. And if we knew that, do that, the first term is just a negative 20x, second term is negative 10h, and the third term is just a positive 5. All that divided by h, and then these h's here reduce to 1, and what we have left with is a negative 20x minus 10h plus 5. And this is our final answer. So this would be the simplified form of the difference quotient when our function is f of x is equal to negative 10x squared plus 5x plus 4. So I hope this clarified some things, and if you need any other type of functions evaluated using the difference quotient, just let me know.